Hi, my name is Henry Sal. I'm president of a company called Computing System Innovations. And we're here to talk about artificial intelligence, robotic process automation, and PDF document processing. How many know what RPA or robotic process automation is? Raise your hands, please. Okay, so several of you are using it in your organization. What we're going to talk about today is we're going to talk about how to make use of it to speed up processing of your documents. The killer app for this is document intake at any organization. We saw yesterday, or we heard yesterday, a lot about accessibility and tagging and metadata for your documents. When we get documents, we don't care about tagging, we don't care about metadata, we actually just process the PDF. We'll OCR it, ICR it, use that data to classify, separate, extract data. And at last year's, or the presentation in DC, I actually explained the technology for how artificial intelligence works up front. A lot of people fell asleep, so what we're going to do this time is we're actually going to show you videos of it in action, and then we're going to go into the details of how we actually use machine learning. So we're going to invent something called lights out processing. That is documents which are never seen by a human. In our production cases for our customers, about 75% of the documents that get ingested are never seen by humans. Okay? A typical customer of ours is a state and local government. They're processing tens, if not hundreds of millions of pages per year. Good example, which we'll talk about briefly, is Palm Beach County. They process roughly 30 million pages per year. They have 200 people doing review of documents coming into their system, enabling artificial intelligence to classify, extract, and using robots to do data entry. They save 150 people doing data entry. That's $6 million a year in full-time employee cost savings they realized. So the combination of AI to process PDF documents, RPA, so that you can update back-end systems, results in significant time savings for organizations that are trying to save money on their document ingestion. CIO voted recently, and they awarded Palm Beach County one of the 50 DES awards, which is the most transformative digital initiatives in the United States. So the technology does work. And why am I here? I'm one of the architects of this solution. Why PDF documents? They are the absolute best way to process transactions if they're digitally born. If you have a digitally born PDF document and you have a text layer that's produced by some word processor or something, you don't have an OCR process anymore. So if you have 100% OCR data, correct data on the document, the AI algorithms are significant and sufficient enough to give you 100% accuracy in recognition of where that field is on your document. The majority of errors that occur in process automation are due to OCR errors. If you have PDF documents that are digitally born, you get rid of your problem of OCR. Briefly, here's a use case. Anybody's system documents coming in, you have a human looking at those documents, doing data entry into a system. Process automation. Documents still come in, AI engines come into play. You do optical character recognition, intelligent character recognition. If there's not a text layer, it may not have to be a PDF document. That information is used to separate a document. Oops, excuse me, I lost my mic. By separate, I mean if you have a blob that contains 15 different types of documents, you'll actually figure out where document 1 starts, where document 2 starts, et cetera, et cetera. You then classify those documents into specific document types. Let's say you have a mortgage. Let's say it's a loan package, and one document's a mortgage. And a mortgage may have different data you want to extract than a closing document. So you have to classify it to figure out what you have to extract off that document. The AI engines kick out certain documents that get looked at by humans. When those data entry errors or that data extraction error gets corrected, it goes back to a robot. And the robot is the principal piece of software that does data entry into the system. Robots are available for many different manufacturers. We are not a RPA vendor. We're an AI vendor. A robot can do the work of about 5 to 7 people. Robot general retail price is about $8,000 industry average. So if you take 6 people at $40,000 a year, $250,000 a year, versus one robot at $8,000, the cost saving is significant. Okay, what we're going to do is we're going to show you actual in production use of this technology. So this is a recording of a state customer, which is Okaloosa County, and they were previously processing these things called arrest reports. When the cop arrested somebody, the cop filled out a report, went to the jail handed the report over to the court. There we go. On the left, 3 different documents, multi-pages. Data's all over the place. There's about 80 different data elements that have to be extracted successfully from those documents to automate the back-end system. We're going to take those documents, copy them from that file folder to this file folder, where our system's monitoring it. There's a robot in the background. This robot happens to be from a vendor called EnableSoft. We're going to show you different vendor robots. It's not really material. So the documents are going to be copied over. The software is then going to OCR, ICR, classify, and extract data, then feed the data to the robot. The robot is running and signing onto this back-end system, which happens to be called Benchmark. It's a case management system, and it's taking the data that was extracted off of those documents, unstructured data, and doing data entry. Error-free and a lot faster than a human can do it. And this would classify as a lights-out transaction. This would run in the background, no one would ever see this. Some stats on this are, there's 85 data elements that come off of those documents. A robot does 425 actions, makes 110 decisions. A human takes 10 minutes per document to do data entry. A robot can do 20 per hour. If a human had to do those 20, it would take them 3 hours of uninterrupted work time. So the concept of using AI to create structured data off of unstructured documents, feeding it to RPA, allows you to automate that document ingestion process. Let's see if I can show my lack of Mac skills right now. Okay, we're going to go to another video. Sorry, Duff.
I gave you a trick computer anyway.
Maybe I should just hang out. So what we want to do is launch it.
Only 5 minutes for the video. Okay. Similar type process in this case, with the exception being these documents are attorneys filing a document off of the internet. Most states in the United States don't have paper anymore. You actually have to do filings online. This happens to be a state of Florida. This happens to be that client that won the CIO DES 50 award. This is a portal. This is a recording of a user signing on to a portal and sending a document into the case management system or to a court. So we're going to speed this up. This is actually a human doing data entry. This is not a robot. They're selecting all the things that are necessary for doing a filing. They're going to submit it. The state portal generates a transaction number, sends that document to the specific courthouse, in this case, Palm Beach County, Florida. It arrives. This is just a workflow monitor saying it's arrived at the system, back at the county. Document's been OCR'd, ICR'd, classified, data extracted. This is another robot. It's an RN to say that this is a robot doing data entry. This robot happens to be from a company called UiPath. The backend system happens to be called Showcase. Irrelevant to what we're talking about. It just happens to be the model what we're showing you. So the robot now is signing on as a user. It's actually mimicking a person. We have clients that call the robots different things. They call them Rosie, Herbie. You can invent them. They're actually users on your system. Data that was extracted was the case number. The robot enters the case number into the backend system, presses the right buttons on the screen automatically through software. We navigate to find the case. And then we're going to create a docket entry, which in the court system is essentially that document has arrived at the court. it's a notice of hearing. The system is classified based upon content. Machine learning technology is classified a document being a notice of hearing. We'll explain that later when we get into machine learning. It's put in a date, time, and room number. It's then going to put the document on the case. And we show up the document over there. There's the time, there's the date, and there's a room number. Doesn't matter where that data is on the document at all. Machine learning takes care of that. We go back to the portal in a couple of seconds. We refresh the screen. And you can't see because the banner's over there, but the document got completed in 2 minutes. Previously, it took 3 days to get that document to the case management system accepted because the amount of workload being done by the government agencies consuming these documents is incredible. Large counties, Los Angeles County is usually 4 days behind in terms of when they do a case filing. Based upon the density of the population, determines how far behind they usually are based upon criminal activity or civil activity in filings. Let's switch over to something more interesting. Okay, these are lights out transactions. These are, no one ever sees this document. Let's show you what happens when a mistake occurs. Thank you very much, sir.
Which one is this?
No, that's the third one. Here we go. And then we only have one more after that. Okay, same type of transaction. This is going to be e-filing, same thing you saw earlier. The difference is that the attorney made a mistake. So what happens with transactions or documents that they arrive at your organization that the document doesn't match what you think it should be? Well, the software is smart enough to understand that the machine learning confidences aren't correct, the OSR level confidences are too low, or there's some back-end data that doesn't match. In this case, the case number typed in by the attorney in this data entry screen is not going to match the contents of the document. So the software is going to do the comparison. It's going to say, oops, somebody made a mistake here. It's going to throw it to a human validation queue. So the document's in flight. A couple of seconds, we'll switch to validation. Now it's in validation. We're going to go to a validation screen, which is an HTML5 client. We'll sign on to it. And the user will be presented with documents they're authorized to see to validate. Document will appear on, we'll click on the batch. Document will appear on the right. Data entry fields extracted will appear on the left. That little orange thing indicates there's a data entry error. When you click on the field, you'll get an eye trail to where the field is. Let's make that bigger a little bit. Click on it again. That's what was on the document. That's what the attorney entered. The user is simply going to take what was on the document by bypassing the field. Those colors over there are machine learning confidences. We'll talk about that later when we get into the designers. They'll complete the transaction by simply saying, done, robots take control. So you now have single screen data entry. You don't have to worry about what your back-end systems are anymore because the robot has memorialized the knowledge of what your data entry clerks were doing. Last one I'm going to show you is a completely different example. One more video, Jeff, thanks. This is actually Adobe. This is the POC for Adobe doing their financial branch of Adobe, doing tax certificates. What happens is you buy Adobe software, people are sending in Adobe tax certificates in email, people are having to read the tax certificates and do back-end data entry into their systems. In this case, we have an email arriving, we have a robot that's reading the email, we have the AI that's taking the data from the robot, you can do data validation, and then we pass it off to some more robots. We're going to show you the first part. Here's an email. There's a tax certificate. So this robot is monitoring various email addresses, variable tax certificate that comes in. Of course, not tagged, no metadata, no XMP stuff. Another type of tax certificate that's coming into the system. Documents are in the HPC, a compute grid for doing OCR. This is not a desk-based system. This is meant to deal with documents in the tens, if not hundreds of millions of pages per year. It's Invalidation. We've thrown these documents in validation just to show you what was extracted off of those tax certificates. So we're switching over to the validation client again. Normally, if the machine learning confidence was high enough and the OCR confidence was high enough, no one would ever see these documents. Here's the first tax certificate. It's going to pop up in a few seconds. We're going to mouse down on the left-hand side of the fields to show you where the data was off the documents that we found. So street addresses, certificate numbers, et cetera, et cetera. Document 1 is done. Document 2 is going to pop up in a few seconds. Granular addresses, certificate numbers, things of that nature. Those are the fields that are required by the back-end application that the system was trained on, and we'll talk about that when we get into the actual applications. And then this is just showing you that we're passing the data off to the robots, and it's structured in this fashion. Happens to be that when we open up the transaction, you'll see a JSON file that will contain both the data that was extracted plus the machine learning confidences of the field. So you use that in your application upstream to determine if that document can be processed without humans looking at it. Okay, that's it for the videos. I have one more that I'll show you the tail end called online learning, but let's talk about the technology, machine learning. Okay, great, that's it. How many people use regular expressions? Pretty fun, huh? Okay. That's a regular expression to find a handprint social security number. Our company's claim to fame was about 15 years ago, we processed the first automated redaction project in the United States from Marion County. We did 7 million images in roughly 7 weeks. Since then, our regular expression technology has done 7 billion documents for 750 clients throughout the United States, including a couple of foreign countries. PII, PCI, PHI. We're RE experts. They're fragile. If your documents change, your regular expressions change. It requires coding skills, a lot of coding skills. When your documents get beyond a certain number of documents, keeping track of all the nuances goes beyond human capabilities. So, about 4 years ago, we decided that we're going to get into artificial intelligence, do machine learning. We acquired the assets from Kofax's KTM team when Kofax disbanded them and said that your product is now in maintenance mode. So our architects have 30 years of machine learning expertise, starting with Sear Systems in the 1990s. Machine learning consists of 2 different pieces of software. There's supervised learning, which is where you set up the system initially by tagging documents. You manually go in and you select on the document where data is that you want to have it extracted or redacted. Essentially found. Doesn't matter what happens, redaction or extraction is your upstream workflow. That's pretty tedious. Sometimes you're entering a new industry. That could be several months of supervised learning. Earlier generations of machine learning technology did not have online learning. Online learning takes mistakes that are corrected by the validation operator and creates new knowledge from those mistakes. So essentially, your system gets better over time and not worse in terms of its precision and recall, fancy words for accuracy. In machine learning, it's also very important to understand that there's something called black box AI, which is you do not know what that engine is doing. Essentially, you feed it documents, and you hope the results get better. So you really don't know if feeding it this set of documents is going to make you better or worse. Later generations of machine learning expose the knowledge, where you can see the knowledge, refine it yourself. I mentioned earlier, upstream applications decide what to do, whether it can be lights out, or it has to go to a human based upon confidence. 2 types of confidences which are important. Did I find the field correctly? So are the AI algorithms reporting back a confidence level that tells you, yes, on this document, I found the word accuracy, and that's what I'm looking for. The next thing which is important is not only did I find it, but were there OCR errors in that field which require a human to correct it? For redaction, it doesn't really matter. Whatever happens to be there. If you have an OCR error, who cares if there's an OCR in the social security number? You're blacking it out. If you're trying to extract the social security number and use it in an upstream application, it better be right on before you start automating your transaction. Accuracy is a misnomer too. Sometimes people think about accuracy on a field level basis. So if I have 10 fields on a document and I'm extracting them and I'm 90% accurate, if I have 10 fields on those documents, on the document, most likely every document that I look at is going to have one field that's wrong. And that document is still going to go to a human set of eyes to review it. That is not lights out processing. Even though a user has less data to validate, it still requires human eyes on. So if you have document level accuracy of 60%, that means 60% of those documents will never have to be looked at by a human. That's where you get your return on investment for processing documents in your workflows. Briefly, supervised machine learning. You get documents, you tag them, the AI software trains, it produces knowledge. Very, very basic. When new documents come in, that knowledge gets applied, documents get classified, data gets extracted, software bots do data entry. That's what I just showed you the videos on. This is very simplified. Here's how you tag documents. You can have extraction based upon zones. Whoops, sorry about that. This got advanced by itself. So this is an accident report. Now this is the same thing that happened to me in DC. My slides started advancing all by themselves. So what happens again, my apologies. Anybody have a clue that why this is advancing all by itself? These aren't, this is a PDF.
Yeah, I didn't add transitions to it.
Can we turn it off in the viewer by any chance?
Well, just try.
It should try it like that.
Try it like that? Okay, thanks. Okay. So 2 types of data you can deal with. Actually 3 types: structured, unstructured, and semi-structured. Structured is zonal. You essentially can say, when you're creating structured supervised learning, you can essentially just tag the field and tell the system, tag the data on the image, and tell it what that field is. Okay? Then the algorithms aren't really AI, they're positional. There's some AI involved because you do page registration to find out what the form is, and you have to take care of skew and things of that nature. In some cases, you don't use image skew. You can do static text. So if you're dealing with a lot of forms, Carfax is one of our clients in this example. You have thousands of forms produced by many sources, and they all come in different flavors and fashions. You really can't tell that this is a state of Colorado accident report by the way it looks picture-wise. You actually have to do vectors off of the static text because it's possible that the forms have changed over the years. And one year they may not have the last name here, they may have the last name up here. So you really can't use visual registration, you have to use static text. It's something called flexible forms that doesn't exist in many applications. Unstructured. This is of high interest to us. We don't care where the data is. This happens to be a notice of hearing. Remember that first document I showed you in the video was a notice of hearing. So I'm providing an example to the system of where the date is on a document, and I'm telling the system that's the event date. So all I do in tagging for AI or machine learning is I tag data and identify to the system where that data is. Then I have a bunch of high-end math. So you have to find content. Once you find the content, you have to identify the content by classifying it in terms of its role. The state-of-the-art engine, or the open source license for state-of-the-art unstructured data recognition, is called CRF, Conditional Randomized Fields. CRF is state-of-the-art. But it doesn't handle the problems if you have words that are spelled alike but mean different things. That's when you need natural language processing. So the concept of having a word that says Sue Smith can mean one of 2 things. It could be, I'm Sue Smith, or it could be, I'm going to Sue Smith. So the fact that the presence of the words are there is 50% of the equation. You need to know what the meaning of the word is, and NLP provides that. So for instance, a proper noun is a name, an adjective may be something I'm doing to somebody. So there's 2 different, that example, Sue Smith, 2 completely different meanings based upon its context. In any event, we don't want to go into the math. The first thing machine learning does is look for visible features of a document. It does document layout analysis. It breaks things into paragraphs, sentences, headers, things of that nature. So you can establish context, because things usually occur within sentences, close to labels, within paragraphs, things of that nature. Relative positioning, what's around what you're looking for that matters. So in this case, I have a courtroom over here, 18B, that the system knows is in this paragraph and happens to be under this label called Notice of Hearing. In addition to non-visible features I mentioned earlier, in addition to visible features, here's non-visible features. What that word means in the English language. Parts of speech tagging occur. Yep, got you, Duff. So, the first thing the system does, machine learning, is to build something called a content locator. And yeah, it builds regular expressions, but guess what? It's not you building them. It's the system building regular expressions. And those regular expressions are used to find content that matters. So if this is actually for a date, it's a date regular expression, it would find the date over there, it would find the date in the filing, all over the place. Once you find all the entities, you have to determine what role that entity has. So on that sample that I showed you, there were 24 training documents. The system found 21 ways to find that event date, directly to the left of something that says on the, hearing, adjacent, and above. So the fact that you establish contextual relevance to where that word was to begin with allows you to create knowledge. Finally, the last thing is how sure we are. So we've taken that knowledge, we've pressed an analyze button, and we've extracted something called a beneficiary, which happens to be a field we're looking for. The system is 99.92% confident we have the right field. So the concept of training the system by providing examples, you actually produce statistics in terms of how the system figures how accurate it is from the machine learning perspective. Last thing, accuracy as I mentioned. This happens to be a mortgage document, nothing to do with courts. I have fields. I have 11 fields, mortgage date down to city and state. Field level accuracy is pretty high. Okay, I'm in the 90s, mid-90s, high 90s. But document level accuracy is 55%, which means that even though my fields are 99% or 95% accurate, only 55% of these documents are going to go through my system without having to have humans look at them. The other 45% will have to have humans look at them, maybe only 5% of the fields, but humans will still look at those. Lastly, the thing, I want to talk about online learning. Supervised learning is great. It requires maintenance. If your documents change in production processing, somebody has to go in and retrain your system unless you have online learning. Online learning takes the manual validation stage, produces a new version of knowledge. That knowledge then gets applied, and when new documents come in, it uses the combined levels of knowledge. There's two types of online learning. There's something called online learning with offline benchmarking and online learning with online benchmarking. Offline benchmarking is you have static test sets of your documents. So when the new knowledge gets produced and gets applied, you have to make sure that your static test set of documents is current. Otherwise, it's not going to be that good. Online benchmarking runs two versions of knowledge in production. It runs your base version and it runs your learned version. Whichever produces the highest score, that's what gets used. That's the epitome of machine learning technology today in document processing, is online learning with online benchmarking. That gives you a system which is an expert system, which self-improves, that never gets worse in the accuracy than you originally created, and always gets better over time. And that's it. So thank you very much. I guess we're open for questions if there are any.